everybody, welcome back. So this one comes from the Berkeley Math Tournament. So what makes this difficult is the tangent. Now I believe this problem can be solved using traditional calculus techniques, but of course that's not how we're going to solve it on this channel. We're going to use a trick. But first, let's start by setting x equal to arctangent u. Then tangent x becomes u, and dx becomes 1 over 1 plus u squared du. And the upper endpoint pi over 2 turns into infinity. Now replace every part of the original integral. The x becomes arctangent u, tangent x becomes u, and dx contributes the extra factor of 1 over 1 plus u squared. Now put a parameter inside the arctangent. Check the two values immediately. When a is 1, we get the integral we want. When a is 0, arctangent of 0 is 0, so the function value is 0. The original integral is f of 1. We do not know f yet, so we find f prime first. This is exactly where the Leibniz rule for differentiation under the integral sign comes in, because a only appears inside the integrand. Here's the rule acting on our exact function. Name the integrand, move the derivative inside with respect to a, and keep the bounds fixed. Inside the integral, the denominator is just along for the ride. Differentiate arctangent of au, then cancel the u that appears on top. Now use a standard partial fraction split. This is routine AP calculus algebra, so we can state the split and keep the main idea moving. Now put that split back into f prime. This is the important substitution step. After the split is inside the integral, separate it into two simpler integrals. The first piece is the standard arctangent integral from 0 to infinity. That gives pi over 2. The second piece is almost the same integral. Use v equals au. That scaling pulls out the factor shown on the slide and leaves the same arctangent endpoint. Now take both evaluated pieces and plug them back into f prime. At this point, the expression is just algebra. Now simplify carefully. The numerator and denominator have the same factor, so they cancel and f prime becomes much simpler. Now integrate f prime with respect to a. Since the derivative is pi over 2 times 1 over 1 plus a, f of a is pi over 2 times log of 1 plus a plus c. Now use the easy value we checked earlier. F of 0 is 0 from the integral version. Plug a equals 0 into the explicit formula, and that forces c to be 0. Finally, go back to the integral we wanted. That is f of 1. So plug a equals 1 into the formula. So the Berkeley integral is pi over 2 times log 2. The big move was to change variables, introduce a parameter, use the Leibniz rule, and then return to a is equal to 1. Alright guys, I hope you enjoyed that, and we'll see you next time.